I'm Wild Bill, and I want to talk about a fossification method or mechanism today. In the Cameroon on the west coast of Africa, there are more than a few active and semi-active volcanoes. Even some of the volcanoes that are considered to be old or dead still leak gas into the atmosphere, or in certain cases into the crater lakes that have formed in the craters of these dormant volcanoes. And so what happens is, over time, a seltzer forms. The ground emits carbon dioxide, oxygen, nitrous oxide in considerable quantities, because that's what volcanoes do. Where do you think the pressure comes from? So, in these lakes in the Cameroon, all is well. You have a series of old mountains, they've got trees all along their sides, there's lush vegetation, the valleys are fertile, the people are beautiful, their livestock are happy. But a geologically active area like the Cameroon is also endangered by the potential for earthquake, seismic activity. And when an earthquake strikes just right, and it's happened before, one or more of those lakes will burp and give up its freight of dissolved gas. Nitrous oxide, carbon dioxide, oxygen, all heavier than air. So an enormous bubble of gas will appear at the top of the lake. It's invisible, but I mean, it's there. You can probably see it in infrared because the emitted gas doesn't have the same properties as the air around it, so I'll bet you can see it in infrared. But at any rate, a giant bubble of gas appears, as if the cork on a champagne bottle blew off, and whew, the champagne is aerated and spurting out into the air. Well, this gas does too, but it isn't quite as localized from the human perspective, because what will happen is this giant, and when I say giant, it could be half a kilometer of fairly high pressure, fairly dense gas. So it's denser and heavier than our atmosphere. Pours down the mountainsides into the valleys and follows the creeks and the rivers toward the sea until it dissipates. Well, since there are villages almost everywhere that there is fertile ground, it's a thing. Humans love to go where it's fertile and then use it all up, planting the same crops over and over again and not returning or recycling, and then moving on and slashing and burning somewhere else. It's our thing. We destroy. We're not very good at building and preserving. It's okay. There are animals that are very good at building and preserving. We just don't happen to be one. Now, this flood, because you can call it a flood, of heavier than air gas will crush all the trees in the way as it falls down the mountainside. And will crush all the trees, and this is how heavy we're talking, will crush all the trees in the valley as it pours downhill, looking for, of course, the sea. In a few of these instances, flocks disappear, people disappear, villages stop contacting each other, and emergency workers will come and find circles of dead, trails of dead, creek beds along which all the vegetation has been crushed, all the insects killed, all the people killed, all the livestock killed, everybody dead, crushed as if by a giant hand, a giant invisible hand of this half a kilometer of gas, half a cubic kilometer of gas. It's a huge amount, and it does weigh a lot. So consider for a moment that if that's happening today, and it's still happening today, it probably happened in the past too. As a matter of fact, I can hypothesize that the farther back in the past you go, the more often that sort of event took place, because the Earth is an energy budget. Over time, seismic activity wastes that energy budget. Obligation from due to tidal processes wastes energy in that system. And it randomizes it as heat or whatever, but still, energy is lost from the system. So over time, the Earth becomes less energetic, not more energetic. The radioactive deposits that do a lot of the closer to the surface heating that caused some of our volcanism was a lot more powerful in the past, was a lot denser, closer, creating more actions. In some places, we think critical reactions. In other words, self-sustaining neutron release fissile events. Underground, South Africa, a couple other places, they're finding that these uranide deposits have the same balance of byproducts in the breakdowns of the uranium in the samples as do breeder reactors. So what they're finding out is that literally underground nuclear reactions were taking place back in the past when, as you go back, those deposits were more energetic. There were more live, non-stable uranide nuclei in the ore samples. And the farther back you go, the louder that is. The louder and more powerful this process has become. You go back far enough, and the Earth was possibly largely molten simply because of the radioactive elements in it, releasing that much heat because they were so high in quantity and relative purity. This is something to save for another log about what was the Earth composed of, the nascent Earth, and how much of what we see today is just the byproducts of radiological degradation of elements, fissile action, neutron release, or capture events. So, if we go back in past 1,000 years, we'll find that these things happen more often. If we go back 10,000 years, we'll find that these events were a little more common. If we go back 100,000 years, we'll discover the same. Go back 1,000,000 years. Yet the Earth was more active. These gas releases happened more often. There was more seismic activity. There was more reason for it. The Earth had more energy, literally, in its system. It's an energy budget, just like almost everything. There's an energy budget available to it. As it spends it, it becomes less energetic. I'm not saying anything heretical here. So what happens is, if you get back to the Cretaceous, let's say, and you find an area that was very fertile, it's likely to be a volcanic area, right? An area that has, if not frequent, then at least infrequent volcanic activity, surface volcanic activity, ground venting of gases from deep in the bowels of the Earth, methane, nitrous oxide, oxygen, carbon dioxide. There's quite a bit of it, nitrogen. There's quite a bit of it down there. And it leaks up through holes in the ground. That's why we have mine gas. That's why they took canaries down to mines in the old days, because methane is odorless and colorless. That's why they add stink to it to make it into natural gas. So you know it's there. Anyway, back far enough, and let's take a moment in time. I'm going to take an extraordinary moment to try to catch your attention. And let's take the Cretaceous Tertiary boundary event. This is, at this time, it is fairly well considered, if not widely accepted, that the Earth was struck one hell of a blow by an asteroid that was somewhere around 100 miles across, back 64 million years ago or so. And when that happened, of course, they say that was the, in quotes, the day the dinosaurs died. We know today that that's not true because birds are dinosaurs. So it is when the non-avian, I forget how to say it, the word's a little different, avian or something, but the non-bird-like dinosaurs all died out in a very short period of time, supposedly. I don't have any special proof that that wasn't the case. Nor do I look for it. I'm trying to find parallels in the geological record that I believe have been slightly misinterpreted. That's all. I'm a quibbler. So when this meteor struck the Earth and gave it one hell of a shot. I mean, we call it an asteroid, but when it hits the ground, it's called a meteorite. Really. When it enters the atmosphere, from the time it enters the atmosphere till the time whatever happens, it's a meteorite. Before that, it can be a meteoroid, or a meteor, or an asteroid, or a plutino, or a TNO, whatever you want to call it, right? But when it hits, when it reaches the atmosphere and begins to superheat and compress the atmosphere, it's a meteorite. Well, so when this 100-mile-across meteorite struck the Earth, theoretically, again, because they refined the theory as time goes on to try to make it fit what people like me say about, hey, wait, you can't do that, you kill everything. You know, then, oh, well, that must have been, okay, so this is all good, part of the give and take of the scientific method when you don't have direct evidence you're trying to infer. It's not empirical science until you have a set of rock-hard, rock-tight experiments that will demonstrate these effects again and again for everyone who wants to know. And that you can tie them together with a wholesome and holistic theory that covers all the observable phenomena. Again, this is not heresy. This is real science. So I'm going to postulate for a moment what might have happened when this asteroid struck us, when this meteorite, this vast meteorite, it's a big piece of rock, really, carrying a lot of energy, by the way. The meteoroids that approached the Earth for what, the Lyrids and the can't take them offhand right now, but the various meteor swarms that we find, periodically, Perseids, that these are moving at quite a considerable clip. So consider that this rock that struck the Earth was probably moving at a considerable clip too. That means there's a huge amount of energy being transmitted between it and the Earth as it strikes. An enormous amount of energy. An enormous amount of energy that would cause what we consider to be solid rock to flex like a trampoline. That flexion would cause certain irrefutable effects, like a wave would travel across the bottom of the ocean. Literally a wave. You could watch it like it's a wave pool. It would lift up the bottom of the ocean, and a big wave traveling away from the point of impact, 20 feet high, 30 feet high. That's a lot of energy being transmitted. That's how it's transmitted. And a lot of energy transmitted by vaporization. So the rock that the meteorite struck would be vaporized, and the meteorite itself, large parts would be vaporized. It would probably shatter. Depending on its composition, it may do any number of things. But we certainly don't find a big chunk of rock down there that looks different from all the other rock. Not that I know of so far. Just finding the crater was difficult. I don't know if there's a gravitic anomaly there or not. I'd have to look that up. But from what I understand, Earth got hit a hell of a blow, and they think, generally accepted for argument is the idea that that asteroid kind of like hit us glancing blow. So you might even think that if it was a pool ball hitting a bowling ball, it imparted energy into the bowling ball, but the bowling ball didn't move too far because compared to the bowling ball, that's not a large amount of energy. However, since the Earth is elastic, bowling ball isn't, the elasticity would allow considerable transfer of energy between the impacting object and the Earth itself. This would create this wave. And I don't mean the standard P and S, I forget what the names of them are, but the underground waves that are transmitted through solid rock and mantle and core, that we can tell you where an earthquake happened because of the length of time differential between when this wave strikes our detectors and when that wave strikes our detectors, because they travel through different regions of the Earth, there are different reflections, different attenuations. In a way, it's a beautiful, beautiful dance of mathematics, as is science at its best. Science, at its ultimate, of course, has vast elements of creativity, because how can you conceive of the ideas without creative minds behind them? Science honors those ideas, but never promotes that sort of thinking, ever. You may take of that what you will. So, when this asteroid struck the Earth, it imparted an enormous amount of energy from our individual human perspective. As a matter of fact, an enormous amount of energy, probably compared to all the explosives that have ever been detonated, it probably exceeded them all by a considerable margin. And likely all the volcanic eruptions that have taken place until that moment, it probably exceeded them by a considerable margin, and therein lies my tale. Every volcano that was not directly active has a volcanic lake in its crater, unless it's in an arid region or an extremely high altitude region. In other words, most volcanoes eventually create a crater lake. Japan is famous for them. Some of the coolest things in Japan for sightseers are volcanic lakes. That one is, it's aquamarine. It's so beautiful, covered with mist and aquamarine, but everything you see is deadly. But it's beautiful. Matter of fact, I used it as the crossing over point into the other world in one of my fantasy novels called Conversation with the Dragon, about the Hogan novel. So anyway, when this asteroid struck, all those lakes, all those volcanic lakes that were probably full of seltzer water, just like the ones in the Cameroon are now, but much, much more, because we're going back almost 70 million years. So hugely more active Earth, hugely more active seismic and geological processes, and the leakage from the ground was probably hugely accelerated compared to today. So these lakes would fill up quick with this air, this dissolved gas, and any kind of seismic activity above a certain threshold level is going to cause the lake to burp. Like shaking up that champagne bottle popsicle. So when that happens, get this, most of the life is going to be concentrated in those areas, because those are the fertile areas. Those are the places plants grow. Those are the places vegetarians feed. Those are the places predators concentrate. All life is concentrated along the riverbeds. Isn't it? A lot of it is. I mean, you've got all kinds of animals that aren't along the riverbeds, but if you look for the density of life, you'll probably find in every era but ours, and even today with humans, that the density of life is completely negligible outside of the biome represented by rivers, lakes, and the ocean, the shore of the ocean. So when all these lakes at once, all over the earth, tens of thousands of them, suddenly burp and give up half a cubic kilometer of gas at once. Now we're talking 10,000 times half a cubic kilometer of gas, or maybe a whole cubic kilometer of gas. Some of these events are very large, even in the modern period. Enough that they leave pressure marks on the ground where the gases pass, crushed vegetation, dead bacteria. It's really something. As a matter of fact, wait, no insects, no bacteria of rot, no mushrooms, no molds, no spores, no living creatures, no scavengers to scavenge, and probably a huge slump of mud as well is blown from the lake, isn't it? It comes down the side. Doggone, does that not sound like an alternative mechanism for mass fossification? Because it sure does to me. The things that you need for fossification to take place are conditions that often when you look at them you think that's rare. No wonder the fossil record is so darn incomplete, no matter how it's presented to you, believe me. It's more like the Library of Alexandria than it is like your encyclopedia. We don't know much about vast spaces of the Earth's timeline in terms of life. A lot of times, most of the life wouldn't fossilize even if we had the right processes in place. But I'm postulating now the reason we have these mass die-offs that show in the rock record is possibly due to various factors, of course, but also this attendant factor of the dissolved gas in volcanic lakes, and the fact that the volcanic lakes are sources of ecology, are members of your biome. Fish live in some of them, even no matter how caustic the environment is. There are extremophiles or relative extremophiles that find no problem living in these odd environments. Imagine a fish living in a crater lake where the dissolved gas is about half oxygen and probably half nitrous oxide. Yeah, I don't care what they're doing out there in the world. I'm pretty high. Holy mackerel. Yeah, you can pull my teeth. What, I'm a fish? I got teeth. I'm a fish. I could have teeth going on. So you see what I mean? There's an enormous amount of gas all released at once when this meteor impacts. As the wave that goes out from it that carries all the energy that's being transmitted to the Earth goes out along the surface of the Earth, all these lakes are going to give up their freight of gas. Now that's one. I'm going to add something similar to this. In the Middle East, we have legends of elemental creatures, wind spirits, the jinni, the dust devils and whatnot. Some of them are considered alive because of the way they act. It cannot be explained by just looking at them and thinking, well, this is how things go. It's what we call now counterintuitive. And so it's easy to believe that these were creatures, living creatures that came and went from the holes in the ground. Oh, yes. Because imagine if radioactivity heating was so much greater 60 million years ago. Imagine what it was like for the boil off of volatile chemicals from petrochemical deposits like oil, where a lightning strike would set a whole plain on fire, and it would burn and burn and burn for months, for years, perhaps forever, till the next event. And that's why we still have that happen today. Lightning strike can set off an oil fire. Lightning strike can set off the volatiles being stored anywhere. And if these are leaking out of the ground, lightning strike will certainly set them on fire, or very likely set them on fire. And that some of these might be persistent. And some of these might be worshipped by people that go like, oh my gosh, there's a fire spirit comes out of the ground up here on the hill. And I throw things in it, and it eats them. It consumes them while I watch. What could explain this except sentience, Godhead? Because primitives don't have the same level of apprehension that we do. They have more intelligence and more creativity than we do. That's been proven. Leaded gas and gasoline lowered the IQ of all of humanity by a few points, and continues to this day, all to make a few very wealthy people a little richer. If I was a vengeful type, I would think, now there's a conspiracy worth everyone gathering against, forcing those people to stop doing that. Pitchforks and torches at the door. But that's just me. And I'm not going to do it. Heck, I'm half kicked in the ass as it is. However, imagine what would happen when that meteor struck and all these volatile oil deposits suddenly spew flammable material into the air, into this plasma wave going through the air, ultra heat. So there's going to be a lot of instant death. There's going to be what we call a fuel air device. They call them butane bombs, hyperbaric bombs. That's going to happen because all those volatiles are going to boil up, aerosol out because of the pressure, be dispersed, and any random spark or friction is going to set it off. Boom! There's a 50-mile square zone. All the dinosaurs dead. Oh, 10,000 lakes. Burp. And there's how many millions of dinosaurs dead? Right there on the spot. Wait. And all the bacteria dead, and all of the saprophytic life dead, all the mushrooms, all the things that would normally enhance corruption and rotting, returning to the soil, right? The cycle of energy would be halted, intercepted, interfered with, so that suddenly, all across the world, the conditions are right for mass fossification. It'll be days before the ecologies recover, years, or months, years for some of it. And if, as some people think, a nuclear winter took place afterward, it could be centuries or millennia until enough balance took place that the regular processes would take over again. And this is how you have the chance, a better chance for fossification, especially whole creatures. And this is also a good explanation for the runoff masses. You'll come to a thing called bone beds in paleontology, where it looks like a flood or seasonal flooding or many, many floods because the number of animals involved has washed the bones of hundreds, thousands of individuals into one little choke point. And they find every kind of bone, every kind of animal from that time period, they think. you know, we weren't there, so we don't really know how this happens. So my idea about this is potentially valid. And this mass extinction mechanism that I'm talking about today is ideal for this process. Ideal. Huge numbers die, natural processes wash their bones down to the choke points. Huge numbers die. And it isn't from the plasma effects we're talking about, because if the asteroid struck us hard enough to have that plasma wave kill all the birds, it would also kill all the fish in the sea. All sea life would be dead because of that giant wave traveling across the bottom would try to raise the sea all at once. And water, well, that would be the equivalent of setting off a depth charge through the whole ocean. All the fish would be crushed. All the mammals would be crushed. All the diatoms would be crushed and shattered. Just like it is when you drop a depth charge. Yeah. Because the whole sea bottom flexes and tries to push all the water above it up 20 feet at what we would consider instantaneous rate. And that would kill any living creature that we know of that was caught in the disruption. So we can't postulate that big an impact anymore as we were earlier. There was this giant thing and the plasma killed all the dinosaurs and killed all the everything. Because if it did, there would be no life left on Earth. And we can't postulate the life returned from the black smokers, which are the thermal vents in the benthic zones of the sea, where a lot of very highly specialized chemosynthetic life survives. It couldn't be there either, because that same impact would blow all the gas that's leaking from those, just like it would from those burping lakes. There would be huge pressure from below trying to force all that stuff up in one big wave. It would kill everything at the base. Kill everything, because the zone would expand. The salt sump, the saline sump would expand in one sudden wave, kill everything. So, this is a mechanism for mass fossification across an entire planet. And it isn't a single evidence item. It isn't just this impact killed the things under it. And it isn't just the explosion, the compression wave caused by that object impacting the Earth and super compressing the atmosphere in the way killed everything in the air. It isn't that. It is a bunch of other stuff that happens, secondary processes that would happen even if it was a lesser impact. Because that greater impact we're talking about that would transfer so much energy, would cause the Earth, parts of the Earth to vaporize, the whole of the asteroid to vaporize, and all that energy be transmitted across a flexible sea bottom, because it is. That's an impossible scenario. That would have killed all life on Earth. There wouldn't be any survivors. Not at the black smokers, not in the Arctic, not in the tropics, not in the mid-ocean column. Nothing. Nothing. Right? No moms. Well, there'd be moms everywhere. Oxygen minimum zones would be like rampant. You know, just kill all the life in the sea, like I'm saying. So instead, you have to have this successive set of processes that take place that are triggered by this impact that can't be as bad as we first presented it. Wild Bill, mass fossification, a new idea, one that I have not seen in any of the literature. Trying to stay current. I'm getting old. I'd like to stay smart as long as I can.